Hello student, welcome to my YouTube channel. This is Dhanjit and you are watching my YouTube channel Bricks and Concept. In the previous classes I already discussed about the concentration of solutions. Now in this class I will take the solubility of a solution. Solubility of solution. So what is solubility? You see, first, solution is a mixture of solute and solvent. So when we add a solute in a solvent, it starts dissolving in the solvent and give rise to the solution. This process is called dissolution of the solute in the solvent. If we increase the amount of solute in a solvent, then a stage will attain where this solute particle will not dissolve in this solvent. Okay, this point is called saturated point. Or saturation point of a solution. And the solution at this saturation point is called saturated solution. After this point, if we add more solute to this solvent, then it will precipitate, the solute molecule will precipitate in the solution. And this reverse condition, it is called as crystallization. So what has happened in this solution, you see, suppose you are dissolving sodium chloride in a solvent water. Then this sodium chloride will ionize as sodium ion and chloride ion. And this solvent molecule will surround these ions. Okay. This process is called solvation process or dissolution process. At the saturation point, the number of these ions become more, and these ions started colliding to each other. As a result, it is start to precipitate in the solution and give rise this crystallization point. So if we try to define the solubility of a solvent, then the concentration of a saturated solution is called the concentration of a saturated solution is called solubility of the solution. So you can say solubility of a solution is the maximum concentration of a solute in a solvent to form saturated solution. So now we'll discuss the different factors that affect the solubility of a solvent. Now we'll discuss about different factors that affect solubility of a solution. In this section we'll discuss about two types of solution, where in one type of solution we'll consider solute as a solid phase and solvent in the liquid phase. Whereas in the other type of solution we'll take the solute as a gas whereas solvent will take as a liquid. First, let us consider the first solution where solute is solid. So factors affecting generally there are three factors that generally there are two factors that affects the solubility of a solid in a liquid. Okay, and these factors are nature of solute and solvent. The other factor is temperature of the reaction. You see, in this case, the principle is obeyed by all the solution, that is like dissolve like, means a solvent with a chemical property which is similar to the solute chemical property that will dissolve that solute. Okay, this means a polar solvent always dissolve a ionic compound, whereas a non-polar solvent dissolve covalent compound. These two things you should know, that a polar solvent always dissolve an ionic compound, whereas a non-polar solvent dissolve a covalent compound. For example, NaCl, it is an ionic compound, it will dissolve in water, whereas iodine, it is an covalent compound, it will dissolve in carbon tetrachloride. It is an organic non-polar solvent. So if you consider the effect of temperature on the solubility of a solid in a liquid, then we will say there are two types of reaction. Okay, this affection will depend upon the type of reaction that is obeyed by the dissolution process. You see, when we add a solute in a solvent, then we will get the solution. During this process, the heat may release or the heat may absorb during the process. It should be heat. What I am saying, if we add a solute in a solvent system, then heat may release in the system. That is, this process might be a exothermic process, or heat may be absorbed in the process, that it might be a endothermic process. If it is an endothermic process, then if we increases the temperature, then solubility of this solution will also increase. This is because this reaction seeks for heat. As we increases the heat, the reaction towards this direction, that is forward direction, will increases. Okay, and the reaction in the direction of backward direction will decrease. While in the case of this, where heat is released in the process, in that case, if we increases the temperature, then if we see, this is a exothermic process, and the reverse process will be a endothermic process. So if we increases the temperature in this case, then solubility will decreases. This is because in this case you see this part of the process will give you this reverse reaction on increasing the temperature. So solubility will decrease. So this is how the solution where solute is a solid and solvent is liquid depend on these two factors, that is nature of solute and solvent and temperature of the process. Now we'll discuss about factors affecting the second type of solution. Okay, solubility of second type of solution, where the solute is gas and solvent is liquid. Here it is the solute and it is the solvent. In this case also, there are three factors that affects the solubility of such solvent, and these are nature of solute and solvent. In this case also, solute and solvent having same chemical property will dissolve each other. That is, a solvent, that is polar solvent, will dissolve ionic gases, whereas non-polar solvent will dissolve covalent gases. In case of temperature dependence, it is also similar to the earlier case. In case of endothermic reaction, if endothermic means if the dissolution process or solvation process is an endothermic reaction, in this case if we increases the temperature, then solubility will increases. If the dissolution process is an exothermic process, in this case if we increases the temperature, then solubility of the solute will decreases. You see, let us consider an endothermic process. Suppose you are dissolving a solute in a solvent, and by absorbing some amount of heat, it gives rise to the solution. Okay, this is an endothermic process because it absorbing some amount of heat from the surroundings. In this case, the reaction already needs some amount of heat from the external sources. If we add some amount of heat from the, if we increases the heat temperature, then we add some amount of heat to this system. So this forward reaction will be increased. The rate of the forward reaction will be increased. So the solubility of this reaction will increase. Whereas in case of exothermic process, where if we dissolve a solute in a solvent, it will give rise to a solution with release of some amount of heat. This forward process is called dissolution, and this backward process is called crystallization, as I mentioned earlier. You see, the dissolution process is a exothermic process, but this crystallization process is a endothermic process, because the solution, if the solution will absorb heat, then crystallization process will proceed, and the solution will give rise to solute and solvent. Therefore, in case of exothermic process, if we increases the heat, then the backward reaction will speed up and it will give rise to the solute and solvent. So we can say in case of exothermic process, if we increases the temperature, then it lowers the rate of the forward reaction. Therefore, solubility of the solute in the solvent will decrease. The third factor that affects the solubility of a gas in a liquid is pressure. This is the very important factors for such solution. The third factor is pressure. This is a very important factor for such solution. You see, if we are considering a solution where solvent is a liquid, this solvent is a liquid solvent, and you have a gas over it, which is the solute component of the solution. Now if we increases the temperature, if we increases the pressure on this gas, then you see the gas will compress. Okay, the gas will compress. As a result, the number of particles that come into the contact with the surface of liquid will increase. Since the number of particles will increase in contact with the liquid surface, that those particles can also go into the liquid. As a result, solubility of this gas solute will increase. So we can say in a solution where gaseous solute is dissolved in liquid solvent, in this case, if we increases the pressure, then the mass that is dissolved in the solvent will also increases. So we can say the concentration of the then you can say the concentration of the solute in the solution phase is directly proportional to the pressure of the solute in the gaseous phase. So this concentration can be expressed in terms of solubility, and there are different concentration terms. If we take mole fraction of the solute, suppose A, in the solution, this will be directly proportional to the pressure of the solute. This you can write as K. So what we have already got, that concentration of the solute in gaseous phase is directly proportional to the pressure of the gas in the gaseous phase. This should be in the solution phase. Okay, in case of a solution where you have the solute in the gaseous phase and the solvent in the liquid phase. So this concentration can be written as mole fraction of the solute. This can be written as K into pressure of the solute. Okay. So pressure can be pressure of the solute can be written as 1 by K into mole fraction of solute in the gaseous phase. This 1 by K is the K each. This is solute and this is pressure of the solute. This is known as famous Henry's law. So if we draw a graph, then we'll get a straight line between P versus pressure of solute versus mole fraction of solute. this type of graph. Okay, and the slope of such graph will give the value of this constant. This is known as Henry's constant. Kh is known as Henry's constant. Though we can explain the dependence of pressure of such solution by Henry's law, there are some limitations of Henry's law, and these are such. Let us see the limitations of Henry's law. The gas we are taking here as a solute should behave as ideal gas at high temperature and low pressure. Okay, this gas should behave as an ideal gas. And another limitation is the gas solute should not give any compound by reacting with solvent molecule. For example, if we consider this gas ammonia, when ammonia is dissolved in water, it will give rise to ammonium hydroxide. In such kind of gas solute, we cannot apply this Henry's law to describe the dependence of pressure on its solubility. Okay, so this is all about the solubility of a solution and its factors that affect its solubility. I hope guys you have understand whatever the things I have discussed here. If you have any doubt, you can comment me in the comment section below. And if you are new to this channel, then subscribe our channel and don't forget to press the bell icon. Thank you.